Hello, dear students. I hope that you all listen me. My name is Alexei Kireenkov. I will give you seminars in the geometry. But unfortunately, the most of people very far from here and in distance region, but fortunately there are a few people who are here in the present in this room. So at the beginning I'd like to ask to all what level of mathematics, of knowledge in the geometry you have now. For instance, do you know what is it, the vector? Who knows what is the vector? 1, 2, 3, you know? Vector. 2 points, yes. Okay. Good news. Who knows the properties of the triangles? Triangles. Yes. Yes. The main properties. For instance, if the triangles have a straight angle. For instance, if the triangles A, B, C is right angles, yes? What's the main properties of these triangles? If the length of this A, B, C. Who can say me the main properties of these triangles? So names Pythagoras theorem. Yes, theorems. Could you please say me? C square equals A square plus B square. Good. I'm glad to see it. So, for instance, a circle. Radius R. Who knows the formula for area of this circle? Area of this circle, S equal. Who knows? S. Area of the circle. I don't listen to you. P R square. Good. So, as we understand, you have an initial knowledge in the geometry. And this semester, we have studied so-named analytical geometry. The analytical geometry based on the vector algebra. At vector algebra based on the matrix, elementary matrix operation. So, at the beginning, I'd like to introduce the elementary properties of the matrix and definition of the matrix. Do you know what is the matrix? Somebody? Who knows what is the matrix? No one. Yes, it's right. So I will begin my speech from the following definition. The matrix of the size m times n is a table of numbers. Usually, for denote the matrix, we have used a capital letters. For instance, A and we have a tables E sub 1, 1, A sub 1, n, A sub m1, and A sub mn. In this matrix, we have m rows, and n columns. So matrix is the table. If the number of the rows equal to the number of the columns, we have so name square matrix. Sometimes you have used the following denotation. N times n is A11, A11n, A sub n1, n sub nn. The first index in the matrix element is the number of the rows. The second row, the second index, j, is number of the column. In this case, we have square matrix. Number of rows equals number of columns. If there are so named elementary operation under the matrix, first of them is transpose matrix. R sub T, so name transposed matrix. The matrix A upper T obtained from the given matrix by replacing its rows by its columns. Transposed matrix. So if we have this kind of matrix, the transpose matrix will the following: RT equal A sub 1, 1, A sub m1, A sub 1n, A sub mn. What we have? Instead of the column, we have the correspondent rows. Example. A is 1, 2, 3, 4, 5, 6. Transpose matrix is, for instance, Sednik, please. 1, 3, 5, 2, 4, 6. The next example. A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Transpose matrix is, tell me please. For instance, you. 1, 4, 7, 2, 5, 8, 3, 6, 9. In the case of square matrix, you can see that the operation transpose is simply symmetry, respectively the main diagonal. The symmetry respectively the main diagonal. It is obvious that AT transpose equals A. In the case when AEG equals AGA, consequently R transpose equal initial matrix, we have so named symmetric matrix, symmetrical matrix. Symmetrical matrix. Asymmetrical matrix. The elements with the same index, the element of the square matrix with the same index, namely R11, R22, and so on, RNN, is so named the main diagonal. Main diagonal of the square matrix. The main diagonal of the square matrix. And the sum of the element from the main diagonal A sub 1, 1 plus A sub 2, 2 plus A sub n, n is so named trace R, trace of matrix. Trace R, or shortly TRA. Trace A, or TRA. The sum of the element with the same index. So consider the square matrix. N times n. A11, A1n, ANN. but all elements below the main diagonal are 0. All elements below the main diagonal is 0. In this case, we have so-named triangles matrix. Triangle matrix. Exactly upper triangle matrix. Triangular upper triangular matrix. If all elements of the square matrix are 0 except the elements on the main diagonal, E equals 1, 0. At the main diagonal we have E 1, and the rest elements are 0. Then solve name uniform matrix. Unit matrix. For instance, unit matrix of size 2 times 2, unit matrix size 2 times 2 is 1, 0, 0, 1. Unit matrix 3 times 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. 0, 0, 1. And the main operation under matrix are practically the same as under the ordinary numbers. And the first of them is sum of matrix. Sum of matrix. This operation defined only for the matrix of the same sizes, namely A size m times n, A1, 1, A1n, AM1, AMN, B size m times n, B11, B1n, BM1, BMN. The sum of this matrix is the matrix of the same sizes. Is the matrix of the same sizes. C equals A plus minus B is matrix the same size, and here R sub 1, 1 plus minus B1, 1, A1M plus minus B1M A M1 plus minus B M1 A Mn plus minus B Mn. If we have a sum of matrix, we have a matrix, the elements of which is sum of the corresponding elements of the matrix from the sum. The next is operation under the matrix. Is product matrix on the real number. Product over the matrix A on the real number, for instance, alpha. By the definition, alpha A is the matrix which each element of them is the product of each element of matrix A to the number alpha. Namely, alpha A sub 1, 1, alpha A sub 1 M, alpha, sorry, A sub 1, 1, A sub 1, 1 M, alpha times A sub 1 N, M sub M1, alpha A sub Mn. As example, let's calculate the following expression. A equal 1, 2, 3, 4. B equal 5, 6, 7, 8. Let's calculate 3 times A minus 2 times B. Let's calculate it step by step for good understanding. So I hope somebody from the room helped me in this procedure. So this expression equals 3 times A. What we have? Tell me. 3, 6, 9, 12. Minus 2, 10. I see, understand. Okay. The student said me that in the YouTube, the student listen only me, not listen you, unfortunately. But in any case, you will say me the results. I will repeat it for YouTube. So minus 10, 12, 14, and 18. Equals minus 6 minus 6 minus, yes, 60. You are right. Minus 7, sorry, minus 6, minus 8, and minus 4. So, the simple example of the operation under the matrix. Simple example of the operation under the matrix. The operations under matrix have satisfy the following laws. The operation under matrix satisfies the following laws. First of them, A plus B equals B plus A. Second, A plus B plus C equals A plus B plus C. The third, alpha times beta times A equals alpha times B times A. Alpha and beta are real numbers. For alpha plus beta times A equals alpha times A plus B times A. 5. Alpha times A plus B equals alpha times A plus alpha times B. The next operation under the matrix is multiplying a matrix by a matrix. Operation of multiplying a matrix by a matrix. A matrix by a matrix. Let's do matrix. Do matrix. A sub Mn. And B. B. N. 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 N times K. Namely, B11, B sub 1K, Bn1, Bnk. We can multiplying not all matrix. This operation is defined if the number of columns of the first matrix has to be equal to number of the rows of the second one. Operation A times B is defined if it's denote if only if. Should if only if. The number of A columns if is equals to number of B rows. Only in this case we can multiplying of the matrix. And we have the following matrix C, the size of which will be M times K. A times B equals C, size M times K. Each element of this matrix, each element of this matrix C sub E J E J equals sum of the product correspondent elements from the correspondent rows of the matrix A by the correspondent elements from the column matrix B, namely A sub E1 times B A sub E1 times B1 G plus A sub En times B N G times B sub Ng. Let's consider a simple example. Multiplying a matrix of square matrix 2 times 2 by a square matrix 2 by 2, 2 times 2. A 2 times 2 equals A sub 1 1, A 1 2, A 2 1, A 2 2. B equals B sub 1 1, B sub 1 2, B sub 2 1, B sub 2 2. C equals A times B equals multiplying corresponding elements of the rows matrix A by the corresponding elements from the corresponding columns matrix B. First element of the matrix C is A sub 1 1 times B sub 1 1 plus A sub 1 2 times B sub 2 1. It's the first element of this matrix. Second element, A sub 1 1 times B sub 1 2. A sub 1 1 times B sub 1 2 plus A sub 2 times B sub 2 2 plus A sub 1 2 B 2 2. So the second row of the matrix C. Tell me please how we can calculate this element. Let's try. A sub 2 1, yes? 2 1 times B sub 1 1. B sub 1 1 plus A 2 2 times B 2 1. B 2 1. And what's your question? So we have a question from the chat, but unfortunately I don't see from the blackboard. But as we understand, this question concerns the previous examples, but that the previous examples is absent now, unfortunately. But I can repeat it for the another one kind of matrix. So here A sub 2 1 times B sub 1 2 plus A sub 2 2 times B sub 2 2. So we have the following matrix. In general speaking, A times B not equals B times A. Let's consider a simple example. Let's A is 1, 2, 3, 4, or 3, 4. E is unit matrix 1, 0, 0, 1. 8 times E equals 1 times 1 plus 2 times 0. 1 times 0 plus 2 times 1. Here, 3 times 1 plus 4 times 0. 3 times 0 plus 4 times 1. In the result, we have 1, 2, 3, 4. The next example. Matrix 0, minus 1, 2, 3, 4, minus 2 times 1, 2, 2, 0, minus 1, 1 equals what size of this matrix will be? Who said me? 2, 2, 2, 2. Okay. The first element, 0 times, tell me, somebody, times 1 plus minus 1 times 2 plus 2 times minus 1. The element with index 1, 2. Tell me somebody. Another one, not you. Maybe you? Zero. First row on the second column. 0 times 2 plus minus 1 times 0 plus 2 times 1. Okay, the next, maybe you said me? Yes? 3 times 1 plus 4 plus minus 2 times minus 1. Yes. And the yellow, please. Yeah. Times 2 plus 4 times 0 minus 2 times 1. Good. So what we have? Minus 2, the minus 2, and plus minus 2. Minus 4. 0, 0, 2. 2. Here, 3 plus 8, 11, plus 2, 13. And here, 6 minus 2, 4. Let's denote this matrix C. Let's calculate the trace of this matrix. Trace C is, who can tell me? Trace 0 minus 4 plus 4 equals 0. Good. Now I repeat the previous examples because there are equations in the chat about the sum of the matrix and product matrix on the real number. A equals 1, 2, minus 4, 7, 3, 0. B equals 4, 5, 1, minus 3, 3, 7. 3 times A minus 2 times B equals. Let's calculate together. Send me, please. Yeah, you. 3, 6, minus 12, 21, 9, 0. Minus 8, 10, 2, minus 6. I minus keep here. Minus 6, 6, and 14. And the result we have minus 5, minus 4, minus 14, no, 21 minus minus 6, 27, 3, and minus 14. Okay. If the matrix consists from only one rows, A equals A 1, 1, A sub 1n. So name matrix row or simply row, and matrix which is consist from one column B 1, 1, B n 1, matrix column. Или simply column. The next example. For instance, A is square matrix 3, 1, 0, 0, 3, 1, 0, 0, 3. E is matrix column or simply column U, V, W. A times E. What we have? Tell me. Maybe you? What size of this matrix? A times E. Column, yes, it's right. What we have? First row of the matrix E, we have time to the column. 3 times U plus V. Next. V plus W. 3 times V plus W. And the last 3W. Good. There are so named elementary operation under on the rows or columns of matrix or elementary matrix transformations. Elementary matrix transformations. First of them, transposition of rows, columns of a matrix. Second, multiplying all the elements of some row or column by the same non-zero number. Multiplying all the elements of some row, column, the correspondent column by the same non-zero number. This operations is transpose matrix. Here I will demonstrate on the Example. For instance, A matrix M times N, A1, 1, A sub 1 N, A M 1, A M N. And one of the elementary transformations of the matrix is multiplying, for instance, first row by the same non-zero elements. Lambda A1, 1, lambda A sub 1 N, A sub Mn, M1, A sub Mn. Example of this transformation. In this example, we have multiplying all elements of the first row of the matrix A by the number lambda, Lambda принадлежит R. Lambda is a real number. The same elementary transformation of the matrix is following. Number 3. Addition to elements of some row column the corresponding elements of another row or column multiplied by the same number. Multiplied by the same number. For instance, A equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's multiply the first row let's multiply in mind the first row of matrix A to the -1 and add to the second row or third row of the matrix. We have 1, 2, 3, 4, 5, 6. If we have multiply the first row on the -1 and add corresponding element of this row to the third row of the matrix A, we have 0, 4, oh no, sorry, 6, 6, 6. Minus 1 plus 7, yes, 6. Minus 2 plus 8, 6. Minus 3 plus 9, 6. Then next elementary transformation is multiplying the second part of this, multiplying all the elements of the sum row column by the same non-zero number. Or simply we can divide it, the rows, the third rows matrix A on the 6. Or times 1 over 6. One, 2, 3, 4, 5, 6, 1, 1, 1. This operation demonstrates these properties. The first operation demonstrates these properties. The matrix obtained one from the another by the elementary transformations are called equivalent matrix. Давайте напишем. Ну, for instance, here. Matrices obtained one from another by the elementary transformations are called equivalent. Equivalent. Usually this is denoted by this symbol. Equivalent matrix usually denoted by these symbols. So, next subtopic. Напишем так. Definition of determinant. Don't remember. Determinant. For any square matrix A can be associated with some value number called the determinant and designated as determinant A, or like this. It's the same. what we read, determinant determinant. It's the value or value some characteristic of the matrix, some characteristics of the matrix. But in the case of matrix 2 times 2, the determinant of the matrix A can be calculated by the simple rule. If A is A sub 1, 1, A sub 1, 2, A sub 2, 1, A sub 2, 2, then determinant A equals A sub 1, 1 times A sub 2, 2 minus A sub 2, 1 times A sub 1, 2. Simple rule. Example. A equals 1, 2, 3, 4. Determinant A or A1, 1, 1, 2, A2, 1, 2, 2, vertical lines. In vertical lines, we have, 1, 2, 3, 4 equals 1 times 4 minus 2 times 3 equals minus 2. Next examples. Да. As concerned the problems book or textbook, they will be announced by lecture. Lecture will announce about the textbook. But there are some problem with textbook in the English because there are many very good textbooks in the Russian languages. And after a short time, we have solved about the recommendation literature. So, unit matrix E 1, 0, 0, 1. Determinant E is 1 times 1 minus 0 times 0 equals 1. Next example. Matrix phi equals cosinus from phi, sinus from phi, minus sinus from phi, and cosinus phi. Determinant phi equals cosinus phi times cosinus phi minus sinus phi times minus sinus phi equals cosinus square phi plus sinus square phi. Who knows the result? Who can tell me about the result of this sum? Phi sum angle. Who can say? Let's consider a right triangle. C, B, A. In the definition, cosinus phi equals C over B. Oh, sorry. Wait. A over C. Sinus phi equals B over C. Cosinus square phi plus sinus square phi equals, who know what I have to write here? Who know the result? One. Equals 1. So corresponds the time of our seminar is finished now. Thank you for your attention, for your time. I apologize for not correct English language sometimes, but I will try to improve it for next time. And thank you. I finished now.